Law of sines. Sine of A over A is equal to sine of B over B. You could also do the same thing with C's. And the law of sine will help us find a missing side or missing angle if you know two angles. So if you know big A and big B, and then you know little a, then you can find little b. Or if you know little a and little b and one of the other angles, then you can find that second angle. And using that, you can solve the whole triangle. The trouble is, the law of sines does not work if you know side, angle, side. So if I had this triangle, ABC, ABC, and I knew this was 10, and this was 15, and this was 30 degrees, it won't work because I know little b and I know little c, but I know angle A. So you would have to use, you would have to use little c, little b, and angle A, but that just won't work. So side, angle, side is out. We need a new equation for that. We'll deal with it later. If you know all of the sides, side, 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 the law of sines will work if you also know one of the angles. So we did that on last week on Thursday. Okay, but angle, side, side is what we're going to deal with today. Angle, side, side works most of the time. Sometimes it doesn't work, sometimes it works twice, and sometimes it works once. So that's what we're going to do today. We're not going to be solving any triangles other than just figuring out, does this situation have no solutions, or does it have one solution, or does it have two solutions? I want to put that away, Cheyenne, and pay attention. Thanks. So, for angle, side, side, let me draw an angle. Let's say this is 45 degrees. Okay, so that's the angle. Now I need two sides. Both of these sides go forever, but I'm going to cut one of them off right here. And to make it simple, I'll call this 10 feet. Okay. Now, I also will be given one more side. Which side is it? Is it going to be the base of the angle, or is it going to be the side that's not listed? The side that's not listed, because it would have to be angle, side, side. If I knew this side, what would it be called? Side, angle, side, in which case the triangle is unique, but the formula doesn't work. You need a different formula. All right. So let's say that this last side was, let's make it easy. So if that's 10 feet, let's say 1 foot. Okay. Is that 1 foot going to create a third side for the triangle? Does it look like it will work? Why not? So if I were to draw a 1 foot circle around this, it would probably be about that big. So this does not create a triangle. Well, let me show you how you tell when you try to do the mathematics whether or not it creates a triangle. So we're going to assume that that side exists and it's a 1. But before we look at that, let's remember our sine graph. So looks like this. How high does the sine of theta reach? From 1 down to -1. Okay? So the most that sine can be is 1. It can be anywhere from -1 to 1. If we go here, let's call this A, B, and C. So this would be little a, little b, and little c. So using the law of sines, the sine of 45 over 1, right? The sine of A over A is equal to sine of C over 10. Now, if I want to get sine of c by itself, what do? I could cross multiply, right? But there's an easier way. How do I move this 10 to the other side? Just multiply it. So times by 10, and I get 10 sine of 45 over 1 equals the sine of c. You can cross multiply if you want, but it's more work than is needed. All you really want to do is move this 10 to the other side. So let's figure out what that is. 10 sine of 45, and divide by 1 isn't going to change anything, but I get 7.07. So 7.07 equals what? What? It's the sine of c. Now, in order to figure out what c is, I need to take the inverse. So, inverse of the answer, and I get error. Why? How come? You're about to know. Good thing you came to class today. Well, I just showed you the sine of c has to be smaller than 1. It can be any number from 0 to 1. But if it's bigger than 1, there is no angle that works. No matter which angle you put, the graph never gets any taller than 1. So, can the sine of c equal 7? No. So what does that tell us about the triangle? It tells us that side A, being 1 foot long, is too short to complete the triangle. That's a problem that everyone in my family has. We are too short to create triangles. So I feel for this side A. So anytime you try to solve an angle side-side problem, and you get to this step, and that number is bigger than 1, that means that the second side is too short to complete the triangle. Okay? Well, how long does it need to be? What? 10? Would 10 work? 10 would work, for sure. Let's not make it too big. Let's try 6. How am I going to test to see if 6 is big enough? What am I going to change over there? Well, does the 10 sine of 45 change? The 1 becomes a 6. Okay? Which really says I'm dividing this number by 6. Is it going to work? Why not? 7.07 divided by 6 is bigger than 1. So this side has to be at least 7.08, or any number bigger than 7.07. So let's try 7.1. Okay? All right, so 10, okay, we'll do 8. 10 sine of 45 divided by 8. Is this going to work? Yes. Now, just because there's one triangle does not mean that's the only triangle. So these angle side-side situations are kind of confusing. So if I put an 8 here, watch what happens. Second inverse of the answer. This is going to tell me an angle 62 degrees, 62.1. So I'm going to, just for today, I'm going to round that to 62. Okay? Now, is that the only triangle that has a 45-degree angle, a 10 on this side, and an 8 on that side? And watch what happens. If we take point B and we make this circle bigger, so that's 1, that would be 2. Will 2 create a triangle? No. What about, we tried 6. Will 6 create a triangle? No. And now we tried 8. Did 8 create a triangle? Will it create more than one triangle? Well, look at these circles. As they come down, there is a circle that touches exactly once. I don't know what it is. We can figure it out, but we don't need to. But if the circle is bigger than that, notice it hits twice. So one triangle is this, 10, 8, 45. What does the other possibility look like? It's a little skinny triangle that looks like this. 10, 8, and that angle is 45. So how do we tell when it has 2? Well, maybe it's easier to tell when it has 1. Okay? What if I kept making this side bigger? How many times would 9 touch? Once for sure. Would it touch a second time? Well, if I drew a circle around here that had length 9 as its radius, how many times would it touch this line? Well, it would touch once there and once over here. What about 11? Why? How do I know 11 can only touch once? Does anybody see it? If I drew a circle that had length 11, it would hit here and nowhere else, because it's bigger than 10. And if that came around, it would miss on this side, right? So if this number is bigger than that number, we automatically know there is one triangle. So this is getting kind of messy, but let's do this again. Well, so we have an angle. Let's say this is 14. Okay? If the other side had length 16, I would draw a circle around this at 16. The only place it could touch is right there, because that 16 is bigger than 14, so this piece here got missed. But if it was 13, then it could hit twice. It could hit here and here. So your job today is figure out, does this create one triangle or two triangles or no triangles? What? No, I haven't started that yet. I'm just overviewing what's going on. Don't worry, I'm not done teaching. So that's basically what you're saying. You're answering the question, is this piece too short to touch it all? How do you tell if it's too short? Well, if that number you calculate is bigger than 1. Okay? If that number is smaller than 1, it could have one answer or it could have two answers. So that's what we're figuring out. So let's say angle A equals 50 degrees, and side A equals 17, and side B equals 14. How many triangles can that make? So it's either 0, 1, or 2. Let's check. Let's draw the picture. Okay, we'll call this A, 50. Where do you want to put the 14? This one? 14, okay. So where does the 17 go? How many triangles fit that? Just one. There's only one possibility. Because can this 17 be moved over and hit it again? So let me try something else. Let's say it was 12. If I swing that 12 over, it will touch again. And then I have, this is my first triangle, and this is my second triangle. But if I swing that 17 over, is it going to hit again? No, because 17 is bigger than 14. So that's one way to tell. If you don't like that way, that's okay. There's another way. The harder way is to do this. So draw your triangle, 50, 14, 17. So we set up sine of 50 over 17 equals sine of b over 14. I want to move this 14 to the other side. 14 sine of 50 over 17. 14 sine of 50 divided by 17. 0.63. Does the triangle exist? Yes. How do you know? It's less than 1. Okay? So we invert, and we find the invert of 0.63, which is 39 degrees. So this is 39. Okay? Now, the other way to tell is the new angle less than the original angle? If the new angle is bigger than the original angle, there are two triangles. If the new angle is smaller than the original angle, there's only one. And I'll show you why that's the case in a second. So, if new is bigger than old, that tells you there are two. Okay? If new is less than old, not odd, old, then there is only one. Can you remember that? Okay. If they're the same size? So, well, that's a good point. So it should be like this. Yeah. If they're the same size, so if this was 14, and I swing this around, it's going to touch right there. In which case, it's not a triangle. It's just two of the same lines on top of each other. So, yeah, if they're the same size, there's only one. Good point. And there's one other case, but it won't end up mattering. All right. Let's look at this same problem, but let's change the 14 to, say, 12. So I draw the triangle, 50, oh, wrong one, sorry. I want this to say 17. No, I want that to be 14. All right, we'll just start over. Your math teacher has no idea what he's doing. There we go. No! Ignore the man behind the curtain. There we go. Is it possible to have two triangles here? Yes, because 9 is smaller than 10. Okay, so let's check. Sine of 50 over 9 is equal to the sine of, whatever you want to call it, b over 10. And times by 10. 10 sine of 50 divided by 9. Does this have an answer? Yes, because that number is less than 1. So let's figure out what the angle is. Invert, and we get 58 degrees. Is there a second triangle? Yes, because the new angle is bigger than the old angle, and the reason that that matters is when I swing this over, this angle matches this angle, 58. And if that angle's 58, and this creates a straight line, this angle is 180 minus 58, which is 122. 122. Now, can 122 and 50 and some other angle make a triangle? Well, 122 plus 50 is 172, so this would be 8. If I had the same picture where this was 50 and this was 40, when I swing that over, that would be 40, which would make this angle 140. Can 140 and 50 and another angle make a triangle? No, because 140 and 50 make 190. We're already too big. So that's why that rule works. So if this number is less than 1, that tells us there is a triangle. Okay? If this number is bigger than that number, there are 2 triangles. Or sorry, there's 1 triangle. That's one way to look at it. Or you make this calculation, you figure out what that angle is. If this angle is bigger than that angle, there are 2. If this angle is smaller than that angle, then there's 1. If they're the same size, then this is what it looks like. If this angle matches that angle, then this side equals that side. In which case, we already knew there was 1 triangle. Okay, so let's do 1 on your paper together. We're skipping 11 through 18. Don't cross them off. We'll work on those tomorrow. Your assignment today is 19 through the end. So take a look at 19. So number 19. So let's draw a picture. A, B, C. C is 63, little b is 9, and big C is 12. Is there 1 triangle, 2 triangles, or none? Can we tell from here? There's 1. How can you tell? We're looking at angle, side, side. If the second side is bigger than the first side, we're going this way, angle, side, side. If 12 is bigger than 9, when I swing that around, it's going to miss, and I automatically know 1 triangle. If that doesn't make sense, that's okay. Write it out. Sine of 63 over 12 is equal to the sine of, what would it be? B over 9. So 9 sine of 63 over 12. What does that number tell me? There is a triangle for sure. If this number is bigger than 1, then there are no triangles. Now we take the inverse of the answer, and I get 55, which tells me 55 is smaller than 63, which means there's only 1 solution. Because if I tried to make a second solution, so this is 55, if I swing this over, and this is 55, that would make this one 125. Can 125 and 63 make a triangle? No, we add those together and we're bigger than 180. So this second triangle doesn't exist. Okay? So each of your answers today on that middle section are going to be 0, 1, or 2. You need to show your work. And then the last 4 questions are just a review of the area formula. And the area formula is really easy. Area equals 1/2 AB sine of C. That's one version. Do you remember what another version is? Well, it's basically that, but it's more complicated. How do I adapt this formula for a different angle? So what if I don't know angle C? What if I know angle B? 1/2 AC sine of B. What's the third version? 1/2 CB sine of A. So basically, if you have side angle side, it's 1/2 times the 2 sides times the sine of the angle given. And that's how you answer those last 4 questions. Okay, can you handle that for today? Tomorrow we'll go back and we'll answer 11 through 18, which is more complicated than what we're doing. Not only do you have to decide 0, 1, or 2, but you have to figure out what the numbers are. Okay, so we're going to skip that for today, and we'll deal with it tomorrow. Right? Good luck.